So here's a video that's going to show why we would rather combine our bulbs in parallel than in series in order to light, let's say, a Christmas tree or lights around your house for decoration, right? You have Halloween lights, Hanukkah lights, whatever you guys hang up, right, to decorate, spice things up. So would you rather connect them in series or parallel, right, is the overarching goal of this video. Well, let's see. Let's connect two bulbs together in a series. So all I did was attach my alligator clip to the positive terminal of the battery, have it enter the positive side of the bulb. I can make either metal, positive or negative, doesn't matter. There's the negative side, so current will flow here. Voltage will drop because it's a series circuit. Current stays the same though, right? That's a property of series circuits. I connected it to my second bulb, and now I'm going to finish off the series circuit by connecting this to the negative end of the battery. And we have a closed circuit now. But what if, let's say, one of those Christmas lights or one of the lights outside of our house on our railing or whatever, our firefly lights, whatever's popular in bedrooms, right? What if one of them goes out? Both of them go out. Why is that? It's because the current here is the same current here. That's what is a property of the series circuit. This is now no longer a closed circuit. This is an open circuit, and it only becomes closed once I have the tip of the light bulb touch the bottom of the middle, because current needs to be able to actually flow through here in order for this one path of current to have current here, if that makes sense. But the idea is that if we had 50 of these in a line, if a single one of them, doesn't matter which bulb was out, if we unscrew this one, this light bulb turns off as well because we still have an open circuit. The circuit is broken. In order for a circuit to be a circuit, a requirement is that you need voltage, current, and resistance in order to maintain being a circuit. Oh, the bulb is being weird. There we go. Okay, so this is series. Now let's compare this to connecting them in parallel. Let me unclip these and show you how to make a parallel circuit. So once again, positive, negative 4.5 volts about. I'm going to connect this to one end of my first bulb. And here's the negative end of that first bulb. It's really bright, right? All I did was create a simple circuit with one light bulb, but I still want to connect another bulb. I want to connect this bulb in parallel, which means that the current needs to split before even entering this bulb. So I'm going to put another clip here so that either current can flow through the bulb or it can travel through this wire. So take this other bulb, make one side positive, and I'm going to take another alligator clip, take another wire, make this side negative, and connect it to the end. So if you notice, both bulbs are nearly just as bright. That's because current split and it didn't drop until after respectively splitting the current. So both voltage values are the same entering both bulbs, which is 4.5 volts, 4.5 volts, 4.5 volts. And at the end, these bulbs are so bright because there was still a push of 4.5 volts through both of these bulbs. So on this side, 4.5, on this side, 0 volts. 4.5 volts, 0 volts. And that means that this light bulb is getting a current of 4.5 volts divided by the resistance of each respective bulb. So 0 volts drops down to the negative end of the battery, where the battery can recharge the electric potential energy up, give it some sort of similar to gravitational potential energy, right? Some sort of potential so that it can drop. So the electrons can actually flow. The electricity, conventional current, I, can flow.